Here I'd like to make a point about the difference between equations and fractions. So we can multiply both sides of an equation by the same number, and we can multiply the top and the bottom of a fraction by the same number. Also, we can add the same thing to both sides of an equation, but we cannot add the same thing to the top and the bottom of a fraction. So don't get tricked into thinking that. So I'm going to write that. So you cannot add the same number to the numerator and denominator of a fraction without changing the value of the whole fraction. So what do I mean? So I think 3 equals 3 is a fairly uncontroversial statement. And likewise, we can add, let's do multiplying first, we can multiply both sides of this equation by the same number. So let's say 3 times 2 equals 3 times 2. So that's 6 equals 6, fair enough. And similarly, 3 plus 2 is equal to 3 plus 2, so that's 5 equals 5. So far, so good. And likewise, let's have 1/10, and that's equal to 1/10 times 2 over 2, so that's 2 over 20. Right, but however, if we got 1/10, that's not equal to 1 plus 2 over 10 plus 2. So that's equal to 3 over 13. These are not the same. So let's take it to a bit of an extreme. So how about if we had 1/10 and we multiply the top and the bottom by 1,000. So that's 1 times 1,000 over 10 times 1,000. So that's 1,000 over 10,000. Oops. 10,000. These are all equivalent. These are all, I haven't changed the value of the fraction at all. However, how about if I got 1/10 and I want to add 1,000? It's not equal to 10 plus 1,000. So that's 1,001 over 1,010. And just take it to a crazy extreme. So 1/10 is not equal to 1 plus 1,000,000 over 10 plus 1,000,000. So that's equal to 1,000,001 over 1,010,000. So the bigger the number you're adding gets, then the closer the overall fraction will get to 1. So you're losing all meaning in the difference between our numerator and the denominator here. So that's just a common mistake people make that I wanted to flag up at this point.